Hello everyone. I am Savan and today I am starting our basics about electrical machines. So this course will go through on from electrical machines and we will discuss about everything that is important. Here we will start from the basics, then DC machines, which will further divide it into DC generator, DC motor, and after that we will go to transformer, three phase, single phase, and after that we will go to AC machines. Here we will discuss about synchronous machine, synchronous motor, generator, and induction machine, three phase induction machine, single phase induction machine, special motors. So, starting from our primary objectives, we will discuss about basic laws that we will need or require to understand the basic working principle of any machine. So, starting from the first law we require, here I am presuming that you have general idea about what is voltage, current, EMF, and resistance, reactance, every basic topic, subtopics, or criteria or anything I'll discuss about. So, firstly, we are discussing about Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. So, just as to specify the main working or main principle, we will shorthand our writing skills. Here, I'll just name the topic, explain the topic, and provide you the notes. These will be available in my description, the link of the notes, or my WhatsApp number or my Telegram group link. So, there you will be able to find every kind of notes related to electrical engineering. So, Faraday's law of electromagnetic induction. There can be two laws, or there are two laws we find out that are discovered by Faraday's regarding electromagnetic induction. The first law tells us about whenever, say, this is a conductor. We will write it as conductor. Whenever this conductor, which is linking to some magnetic field, if the magnetic field linking to the conductor is changing, I repeat, whenever the magnetic flux linking with the conductor changes, say it is initially at phi I and changes to phi f, then it is known as dynamically induced EMF. And for the second case, if the flux linking to the conductor or the conductor cut the magnetic flux linkage, there are two separate things. First thing tells us about, say, the flux changes alternatively. Due to this change of flux, we say it we say it statically induced EMF. Statically induced EMF. For the second case, if we say, and suppose it is a rotor with copper conductors, magnetic field path, if the conductor is rotated in this direction and the magnetic field lines or magnetic flux is cut whenever this conductor rotate, so as to suppose the point is here and it cut down the flux, then this phenomena induces EMF2. This is known as dynamically induced EMF. This is first law of Faraday. Here we discuss about two things. First is statically induced EMF, which is induced due to the change in flux linkage across a conductor or by a conductor or through a conductor or in a conductor. In second case, we read about dynamically induced EMF, which is induced due to change or cut down of magnetic flux linkage to the conductor. So basically, whenever the flux changes or cut by a conductor, EMF is induced. And for the second case, we have when that the EMF induced due to flux cutting or changing, this is equal to or say directly proportional to change in flux with respect to time, as there can be n number of turns. EMF will be equal to or directly proportional to n d phi by dt. Here E can or EMF can be written as, here this negative sign appears due to Lenz's law, which is our second basic law we require. So the second law is Lenz's law. As per this law, the current flowing in the conductor or the EMF induced in the circuit always opposes the cause of producing it. Since suppose this is a rotor and due to rotation the flux is cut, through which dynamically induced EMF is induced in the circuit. This EMF now oppose the cause of production, which is magnetic flux. So this negative sign appears to show the opposition of EMF to flux. I hope you all understand what I am trying to say. After that, some basic laws which we define as Fleming's right hand rule, left hand rule, right hand thumb rule. I'll write them as usual. Fleming right hand rule. Fleming left hand rule. And last one is right hand thumb rule. So here Fleming right hand rule tells us about that according to this rule the When we stretch our middle finger, index finger, thumb of right hand such that all of them makes 90-degree across each other, say x, y and z axis. This is x, this is y and this is z. So the thumb will point out to the direction of motion. The index finger will point out to the direction of magnetic field, and the index and the middle finger points out to the direction of current. However, in Fleming left hand rule, the middle finger points out to the direction of EMF. So basically, there is a simple change and a single difference between them, which is the direction of current or EMF pointed by the middle finger. Otherwise, both the rules are same. However, their applications are quite opposite to each other. So, the last rule is right hand thumb rule. Suppose I just stretch my fingers and straighten up my thumb. Now, my thumb will point out to the direction of current, and my fingers, just like the wrap, points out to the direction of magnetic field. Say this is a conductor, I is the current flowing through it, and say this. So this will be the direction of magnetic field. Is it simple? I think we are going in the right way. So for today, it is enough. We will discuss and we will go through the DC motor or generator action tomorrow. So be prepared. We will discuss the upcomings tomorrow. Thank you for the day.